Hey guys, welcome back. This is our final video for section 1.2. I'm going to try to make this video short and quick, which means that I'm basically not going to do a lot of the row echelon form. You can pause the video and confirm my answer, but everything is perfect, so I didn't make any mistakes. Okay, so in this last two examples and this last video, we're going to discuss a system with infinitely many solutions. Now, this is extremely important. In order for you to have infinitely many solutions, what's going to happen is we're going to need basically more variables than equations. So for example, I only have two equations here, but I have three variables. So what's going to happen here is we're going to have that parametric representation. And so I'm going to just do the coefficients 2, 3, 4, 5, negative 2, 0, and then the 0, 1. So this is actually called an augmented matrix, okay? I did my row reduction. You can pause the video. Remember, our goal is to make this person 1, which I did, and make this person 0, which I did. And actually, this is also not only row echelon, this is reduced row echelon because I have a 0 above and below, and here's my main diagonal, okay? So what happens here now? I basically have x to the first, sorry, not x to the first, x1 plus 5x3 is equal to 2, and then I have this x2 minus 3x3 equals negative 1, okay? Remember, these are the constants, okay? What I'm going to do is I'm going to make x3 equal to t. And I chose x3 for a few reasons, but one reason is because x3 is in both of these cases, okay? It's in the first one and the second row, okay? So we did that, and then all you have to do is solve for each one. So x1 is equal to 2 minus 5x3, but x3 is t. x2 is equal to 3x3 minus 1, but x3 is t. So anytime we throw in a t, which is any real number, we'll have a solution. So if t is equal to, let's say, 0, then x1 is equal to 2, x2 is equal to negative 1, and x3 is equal to 0. Okay? There's infinitely many solutions here. The final piece of this chapter is actually really important. Homogeneous systems of linear equations is basically a system of linear equations in which each of the constant terms, remember what constant terms are, it's the last one, that's why it's important for the definitions, is 0. A homogeneous system of m equations in n variables has the form this. So we have an equation equal to 0. We have an equation equal to 0. We have an equation equal to 0. A homogeneous system must have at least one solution. If you think about it, we're solving for x1, x2, x3, xn, and it has to equal 0. So we know it has to have at least one solution. Specifically, if all variables in a homogeneous system have the value of 0, then each of the equation is satisfied. Isn't it true if I make x1 0, x2 0, all of these will work, this will work, this will work, this will work? Sure. So that solution is what we call trivial, okay? Trivial means like it's obvious that 0 works. How do we solve something like this? So I want to show you something before I begin. Okay, I have, this is a homogeneous system of linear equations, and that's because our constant's equal to 0. I took all my coefficients, 1, negative 1, 3, 0, 2, 1, 3, 0, and I did row reduced echelon form, right? It's in fully reduced form, and this is what I ended up with, right? Once again, I have x3 to be t, x2 to be t as well. Okay, let's check the math here, x2 equals x3. And then x1 is equal to negative 2t. Okay, so we made x3t, and then we solved it in terms of t. Here, this system has infinitely many solutions, one of which is the trivial solution, t equals 0. So in this case here, we have infinitely many solutions. Trivial solution is t is equal to 0. And when t is equal to 0, x1 is 0, x2 is 0, x3 is 0. We also have t can be 1, so that's -2, +1, and so on. So what we're going to do here is we basically set it equal to 0, 0, and do that here. Okay? Here's our theorem. Every homogeneous system of linear equations is consistent. Moreover, if the system has fewer equations than variables, then it must have infinitely many solutions. That's what I discussed earlier. If you have fewer equations than variables, you're going to have infinitely many solutions. I wanted to end up leaving you guys with this final example. We're going to learn about this sort of format in chapter 2, but it's pretty simple. Example of solving the homogeneous linear system of equation. A is the list of coefficients, okay? X is just the variables, and equals to 0 is basically, you can rewrite this as a bunch of zeros, okay? And this is what it means to be a homogeneous linear system of equation. AX equals 0. The way that we look at this is we say 2 times x1 plus 3 times x2 plus 4 times x3. We're not going to use these numbers. I'm just trying to show you that's how you write the system. So you go across and then down. 1 times x1, 5 times x2, 6 times x3 equals 0. These are called our coefficients because it's not an augmented matrix. It's a coefficient matrix. You remember those from the first video of this section when we talked about keywords? When there's no answers, you know, the last column, when there's none of the last column, when this last column is not there, it's just called coefficient. And so here is the example that I'm going to start, okay? AX equals 0, A is equal to -1, 1, 1, and these are just, again, coefficients. These are not the answers. These are not the constants. Explain why there are no solutions, an infinite number of solutions, or exactly one solution. This is the question. And you guys should all say, wait, if this is a homogeneous system of linear equations, I'm going to cross out no solutions because I know there has to be at least one, which is the trivial. So what I did here, guys, was I took this here, okay, and you can confirm everything, and I did a row reduced as much as possible by doing these two operations, and then I did some more here by doing this operation, okay? So you can pause the video, take a look at it, but I basically row reduced this. You'll notice in my next page, this is a 1 here. What does that mean? This means -1 x to the x1 plus x2 minus x3 equals 0. 2x2 minus 3x3 equals 0. And then we got x3 is equal to 0. If you notice, since x3 is equal to 0, we put 0 back into the second equation by doing back substitution. x2 will be also 0. x1 will also be 0. Okay, so you have only the trivial solution here. But when you're solving homogeneous system of equations, guys, have this format, and then you guys can also basically have, it doesn't have to always be 0, 0, 0. You can have, you know, in terms of t, right? So like -2t, t, and so on. So you can have different representations, just like this here, okay? But the way that we solve homogeneous linear system of equations is you basically want to take the coefficients and reduce them, okay? Reduce them as much as possible. Do you need to just take the coefficients? No. But a lot of the questions are always given with just the coefficient because it's almost silly to put zeros here at the end. So watch out for coefficient matrix versus augmented matrix. So I hope that makes sense. I hope I didn't go too fast. Row reduce the coefficient. Get it down so you can solve for one of the variables and then start solving for the other variables just like we did in terms of t. Okay? I hope everybody has a great weekend, a great day. Take care.